Let's take a look at reference angles. As we move around the unit circle, the idea of reference angles is going to be very important in trying to evaluate sine and cosine of various angles. First of all, which quadrant contains the terminal side of each position angle? If we start with 45 degrees and just draw it out, remember with a position angle, the initial side is the positive x-axis. 45 degrees is halfway to 90, so it would be right here. Since that terminal side is in the first quadrant, we say it's going to be in quadrant 1. For pi over 3, remember that here's our initial side. Pi radians would be over at 180 degrees, so if we were to take this entire arc and break it into thirds, there's 1/3, meaning that the terminal side here would be also in quadrant 1. If we're looking at 4/3, again, here's pi. 4/3 is larger than 1 pi. And if we thought about breaking that into thirds, well, this would be 1 pi over 3. Here's 2 pi over 3. Pi is 3 pi over 3, so if we went another one, now we're at 4 pi over 3. So here is that angle, meaning the terminal side is going to be in quadrant 3. For 285 degrees, as we go around the circle, our initial side, here's 180 degrees. Adding 90 degrees to that means that this one's 270 degrees, and so we would have to go a little bit further to get to that 285 degrees, making 285 a quadrant 4 degree measure. For 90 degrees though, that's right here. The question asks which quadrant contains the terminal side. Well, quadrant 1 is over here and quadrant 2 is over here, and 90 degrees is kind of in between them. All right, that makes any right angle a special kind of angle, and we call that quadrantal. Quadrantal angles are going to be angles whose terminal side lies on the x-axis. So in one trip around the unit circle, there are 4 quadrantal angles. We could have this angle, which would be 0 degrees, or 0 radians. When we get to that 90 degrees, remember that's the same as pi over 2 radians. Another quadrantal angle over here would be at pi or 180 degrees. And the fourth one is the other one that lies on the axis, and that's going to be 270 degrees or 3 pi over 2. But the big idea I want to talk about is the reference angle. And a reference angle is the angle formed by the terminal side and the nearest x-axis. See, when we're dealing with any acute angle, any angle that's in the first quadrant here, right, its reference angle is whatever the angle is, right, because that's the angle that it makes with the nearest x-axis. However, as soon as we get out of the first quadrant, things can become a little bit trickier. For instance, let's say that we're in the second quadrant here, something like this. Here we have an angle whose terminal side is definitely more than 90 degrees. And finding sine and cosine of that can get a little tricky. Would be a lot easier is if we had another angle that we could reference that would act in the same way. And that's where the reference angle comes into play. The reference angle is going to be the angle that it makes with the nearest x-axis. Since we've gone past 90 degrees, it would be a lot closer to get to the pi measurement or the 180 degree measurement than it would be to work backwards over to the 0 degrees or 0 pi measurement. So when we have theta over here in the second quadrant, we're just going to want to start with that 180 degrees or pi radians and subtract theta. If we get into the third quadrant down here, this is our angle theta now. And we want to find the angle that it makes with the nearest x-axis. So we would just start with theta and then subtract the 180 degrees. If we make it into the fourth quadrant, so we're talking about an angle that's over here. Here is my angle theta. Then we want to see how far it is to the nearest x-axis. And if we were to continue on, this 0 would actually be a completed circle and turn into 360 degrees, or 2 pi radians. So to find its reference angle, we would start with the 360 degrees and subtract off our angle theta. So let's try a couple. Let's find the reference angle for 5 pi over 3. What's important is to recognize where is 5 pi over 3. And if we put it in standard position, here's pi. Remember that for thirds, that means we take our entire arc and break it into thirds. 1 pi over 3, 2 pi over 3, pi is 3 pi over 3. So we're going to have to continue to 4 pi over 3, and 5 pi over 3 would be right here. When we want to identify its reference angle, that's going to be the angle that it makes with the nearest x-axis. That positive x-axis, if we were to continue along, is now at 2 pi radians. So to find that difference between them, we just take 2 pi minus 5 pi over 3. So we're subtracting fractions. Let's get common denominators. Multiply this first, 2 pi by 3 over 3, and we'll get 6 pi over 3 minus 5 pi over 3 for a reference angle of pi over 3. So that's what this angle would be in here. Let's find the reference angle for negative 130 degrees. First, identify where that angle is. Initial side, positive x-axis. Since we're dealing with a negative angle, we're going to have to work down. So we'd swing down to 90 degrees, and then 180 is over here. So 130 must be somewhere in between there. So this angle is negative 130 degrees. Its reference angle would be the angle it makes with the nearest x-axis, right? That acute angle right there. And so we need to find the difference between, because we're going backwards, this is negative 180 degrees and our negative 130 degrees. So negative 130 minus negative 180 gives us 50 degrees. A couple things about that reference angle is, first of all, that reference angle should always be a positive number, and it should always be an acute angle. But the reference angle is the angle it makes with the nearest x-axis.